Hi. First of all, let me thank you, CAP, for having us. I am Faraz Dadgostari from University of Virginia Systems Engineering Department, and this is a work with Peter Billen from the same department, Michael Livermore and Maurizio Quim from UVA Law School. And I'm gonna explain to you about how we gave a simplified definition of search in law, developed some algorithms to replicate that, and evaluated them. Okay, what is search in law? We define search in law as a part of case selection procedure for a given legal question, aiming to make a proper legal reasoning. Then law search is defined as a part of the case selection, and we call case selection something as information gathering process or knowledge acquisition process. We make the definition of law search in that context. Then to make a formal model of such a process, information gathering process, case selection process, we need to start from textual documents, say, for example, US Supreme Court opinions. Then we use language modeling, citation information, etc., to define a measure of similarity between opinions and then a notion of distance between them. And this makes it possible to construct a geometric spatial representation of legal documents, textual documents. As you can see, the black circles are each one of them is a textual opinion, and even a legal question, we can represent that somewhere and locate that in the middle of those documents. And having this, we can start thinking about how we can navigate over these documents strategically to make a proper case selection, and then search is a part of that. Then to do so, we have developed, we have developed 3 algorithms, and the other one is there, and the 2, I don't know why it continues the other way. Then we have developed 3 algorithms. The first one is proximity method, which is the baseline, and then the next 2, which I will go in depth more. Then each of those algorithms have an underlying conceptual framework. And the simplest one, the proximity method, has this conceptual model, which is so simple, like what we do every day on Google. We have a question, we search, it returns a ranked list of documents, and then we just get to select the top, say, 4 of them. And this is a very simple conceptual model, and if we want to write an algorithm based on this conceptual model, we will end up just with selecting the closest document to our legal question, which will end up to be something like this. And as you can see, there are a lot of redundancy in these results. You know, these cases, these blue cases, are so similar to each other, and we may want to do something a little more complicated. And in fact, if we take a step back and see search as a part of that case selection procedure, information gathering procedure, then we may end up with a better conceptual model of search, in which instead of a single search line, we first decompose a legal question to smaller questions, and then, for example, we make a first search on top for the first object, and we learn some stuff, and then we use what we have learned in the first search to do the second, and then we use what we have learned in the first and second search to do the third, and we go on and on up to the point that we have selected enough cases for our legal reasoning, and it's not a ranked list of documents, it is a proper set of documents. And then if you use this conceptual model to develop a model, which we did, you may end up with some result like this. We call the algorithm designed based on that conceptual model covering method, and as you can see, compared to proximity method, it doesn't really look for the closest documents, but more on how it can cover all aspects of the legal question, the red circle. And in fact, that we made that conceptual model based on our interviews with law students and said, okay, how you do this? And they just explained us, and we made that conceptual framework, and they learn how to do this formally in the first month of the law school. They learn about this conceptual model, and then they build this search algorithm in their mind, and they just implement it. Then what happens next in law school, in next years of law school? Based on what we have learned from them and the way law is taught in law school, it seems that they actually they make examples and train over different legal cases. Then in each course, they have to go through different cases of, say, for example, US Supreme Court, and see how Supreme Court actually do this case selection and make reasoning based on that. And then they try to see what they would do and compare and learn. And this case practice happens during the education. Then it makes a first-year law student a professional lawyer. And well, this loop of learning based on different cases in different classes actually updates the initial algorithm which was in the mind of the law student at the early law school. And this search algorithm is actually being tuned over that education. And if we try to kind of formulate this loop of learning, we'll end up with some concept we have in machine learning, which is reinforcement learning, which kind of replicates this, try and error and feedback and updating your search algorithm based on what you see experts do. In this case, for example, US Supreme Court judges. And this is just the formulation of that simple loop of learning in a more formal way. And I'm happy to go in depth with this, how we actually make this equivalent formulation, but I will go on to have the time limited. And if you use that conceptual model of learning, which we did, and train that model based on, say, for example, US Supreme Court opinions, you may end up with a different strategy of navigating through legal documents, which in this case you can see, instead of 3 topics, you have just 3 subjects, you have 2, and it is a little different than the covering method. And to see what is the performance of the algorithms, we designed 2 tests. The first test is we remove the citations of 500 US Supreme Court opinions, and which makes citation-free legal documents. We call them CFLTs, and we we asked search algorithms to predict the citations of those documents, and then we compared what they have predicted with the actual citations of US Supreme Court opinions, and comparing that gives us a good measure of performance. And these 2 measures, precision and recall, are conventional measures in information retrieval to see how well we are doing. And as you can see, from proximity to covering to adaptive method, which is the learning method, we are getting improvements pretty well. But since there are many problems, flaws in these measures, and information retrieval community struggle with that, and also that this measures doesn't make sense for law scholars, then we made a second test in which, instead of 500, we just removed the citations of 10 US Supreme Court opinions, made again CFLTs, and used our algorithms to predict 10 citations for each CFLT. And then we asked 7 law students to do the same. And then we compared how law students overlap with each other with how law students plus one of these algorithms overlap with each other to see how well they are doing. And in our test, we ended up with these numbers. As you can see, inter-student overlap average is 27 to 38. Then the performance of human being is something between 27 to 38. And then when you use proximity method, you get just 6. And 27 to 38 is out of 100 possible overlaps. Then for proximity method, you just get 6 overlaps with the students. Covering method gets 9 overlaps with the students, and on average for each student. And adaptive method gets to 17, which is kind of close to the bad students in this case. And we are trying to make our bad student, algorithmic student to get a little better, but for now I think it's a good initial results, and we are looking to see how we can use the CAPS data and maybe search feedbacks, data to make our models work better and train them. And yeah, that's it. Then for future, mostly we are looking to extend our modeling framework, make and extend our domain to other than US Supreme Court opinions like US code and regulations, and Also, we are working now on measuring complexity of documents based off our representative approach, and many other things we are trying or planning or having idea to work on, and CAPS is a very good opportunity to make all of them happen. Thank you. That's it.